Hi everybody, it's me Instagram again. Hi everybody, it's me in Instagram again, and all the other channels that I'm out there. Please subscribe, follow, and become a sponsor. I guess a subscriber of my thing. And like anything you like, and just continue to follow along. And right now we've got our shredded chicken. It looks like it's doing pretty good. I'm going to toss it around and see if it's completed. It looks like it has about 25 more minutes left on it, but I think it's looking pretty like it needs to be done. So the rest of the ingredients I'm going to start cooking up right now and get those ready so that they can be for the tacos. And evidently that's all we need to get done. Got myself a fork here. Oh yeah, these are good. These look really good. They're done. So now I can bring them out and we're going to chop them up or shred them up and put them back in here in the ingredients because we're going to use all the ingredients and the juices also in our mix.
Shoemaker was working on craters left by nuclear explosions on test sites in Nevada. His task was to find out how the explosions transformed the landscape. At the test sites, he found the exact same rock formation Barringer described in the mysterious meteor crater in Arizona. Shoemaker passed away in 1997, but his wife, astronomer Carolyn Shoemaker, recalls his findings.
James compared meteor crater with the craters that he had been mapping at the Nevada test site. At the test site, James saw overturned beds, also near the top of the craters in the rings, and that certainly told him that there was a strong similarity because they were so obvious in meteor craters.
Shoemaker came upon another important clue that links the Nevada test sites to meteor crater.
He found samples of this unusual rock. This was once sandstone. He recognized it had been altered.
In the craters left by explosions from nuclear bomb testing, Shoemaker discovered crystalline structures, the same structures found in Arizona's meteor craters.
Today, we understand that this is shocked sandstone glass. That is, the original sandstone. All of the quartz crystals were melted and put into a frothing, bubbly glass matrix, which we have.
I'm going to get our hominy going while I'm out in here too. Get it all started up. Add it to our food.
For Shoemaker, it was conclusive that the vast meteor crater wasn't formed by volcanic eruptions. Instead, it was created by a thermal asteroid impact in just a split second. The shock rock also gave scientists a clue about the age of the crater. When an asteroid hits the Earth, the energy from the blast is absorbed by the surrounding rock. Using a process called thermoluminescence dating, scientists are able to measure the amount of energy the rock is giving off in the form of light. The shock rock from meteor crater shows that the impact happened 50,000 years ago. But for some, there remained one problem with this theory. If the Arizona Earth was crushed by a huge asteroid, where was the rock that made the impact? Scientists had a hunch that when it struck, the iron meteorite had vaporized. Conclusion that this came in 1997, when scientists were able to simulate the impact using advanced computer modeling. The crater, they calculated that the asteroid must have weighed at least 300,000 tons when it struck. The data further revealed that it hit Earth at a speed of over 25,000 miles per hour. That's 35 times the speed of sound. asteroid triggered a massive shockwave, many times more powerful than a nuclear explosion.
Within a matter of seconds, the impact crater behind me was excavated and the debris was deposited on the landscape within seconds.
Get that chicken cut shredded here.
Velocity air blast radiated across the landscape.
The shockwave traveled back up through the asteroid's iron core, vaporizing most of it, scattering the rest in small pieces over a wide area up to 6 miles away.
The energy that produced this crater ranges somewhere from a few hundred to perhaps 2,000 times greater than the energy that destroyed the cities of Hiroshima and Nagasaki in World War II.
The investigation has uncovered reasons why there are no big remnants of asteroid rock in the Arizona crater. Crystalline structures in the rock showed evidence of a strong shockwave that followed the impact. Computer model revealed that the speed and size of the asteroid
Oh yeah, these are
created
perfect.
enough energy for the rock to vaporize when it hits.
This crater is
Falling apart pretty much. I'm just tearing them with the knife because I don't want to use my fingers because they're awfully hot. Man, they just came out of the oven. They're out of that crock pot there.
So it is in some sense the Rosetta Stone. It is the touchstone.
They're juicy too, I'm telling you. There's some really good chicken here.
To study and learn about impact cratering as a geologic process.
Since 1960, when Shoemaker proved that Meteor Crater was an impact site, geologists went looking for more.
Pretty good.
This new information and the developments in space and satellite technology, they would revolutionize our understanding of how asteroids have shaped the surface of the Earth.
Sorry, I couldn't wait. It's way too good.
Once the Meteor
Have to
Crater in
test it.
Arizona proved an iron mass can burst from space and create a monster chasm, scientists began to search for others. They questioned whether some craters they thought of as volcanic were in fact caused by asteroids. The investigation turned to Sudbury in Ontario, Canada. There is no obvious crater, but for over 150 years, the city has been the center of fabulous mining wealth and a geological
Perfect.
district. 3,000 feet below ground in one of Sudbury's mines, 6 veins, copper and nickel are on view. Until recently, these mining riches were associated with volcanic activity.
One of the really distinctive features of Sudbury is the fact that it has world-class.
Actually, I don't think we're going to put it back in there. We're just going to set it up beside here where we make the tacos and things. I'm going to clean this off real quick.
Volcanic activity and movements coming from inside the earth, bringing all from the inside.
The substance add up. When scientists investigated the rocks around the mine, they were surprised. None of the outcrops were typical of the types of rock created by a volcano. To geologists, it was a hint that the copper and nickel treasures below the surface were formed by a different process. They were stumped until they came across Eugene Shoemaker's work on Meteor Crater. It made them wonder whether this vast mine also
Vegetables.
was formed by an asteroid impact. Could the vast reserves of copper and nickel have arrived from space? Rocks above ground
Make this
revealed
simple, quick.
What we have is a fossil-type fracture system with the lineations or lines to eliminate. They focus down into a point.
These deformed rocks are called shatter cones. Spray is convinced that the only force powerful enough to deform a rock into a shatter cone like this would be an asteroid impact.
Now these are formed due to the shockwave interacting with the target rocks. And they compress the rocks just like in a spring, and then when the shockwave releases, they form these conical-like structures, which are beautifully shown here. So these are diagnostic impacts. You can't form them any other way. You can't form them with dynamite. You can't form them with nuclear
There's
weapons.
that. Those.
But shatter cones
But it's also
were
on its plate.
Another clue came from the composition of the rock. It's a mixture of violently broken pieces fused into melted material.
So what we have here is made up of the debris from the Earth's crust blasted into millions of pieces, and the darker core material may well contain traces of the meteorite left in it in the form of iridium.
Iridium is one of the rarest metals on the surface of the Earth. In space, it is 1,000 times more abundant.
How many just got boiled?
Are like space rock.
Got about another 5 minutes.
It varies dramatically. Some are made of rock-like material, some from metals such as iron. But they all have one thing in common. They all contain comparatively large amounts of iridium. So any high amounts of iridium found on Earth becomes a fingerprint of an impact event.
So what we're going to do is take a sample and analyze it to see if we can find an enriched iridium signature, which will tell us that we have a particular class of meteorite.
To find iridium, the lab samples of the crushed rock are heated in a furnace to over 1,000 degrees Celsius. The rock melts, and metals in the rock separate out and form a disk. When the disk cools, it is analyzed for traces.
You're not going to need a lot of onions, but you're going to need some.
Metal from the rock is dissolved into liquid. It is passed through a mass spectrometer capable of spotting tiny metal parts. This incredibly accurate device provides the vital piece of evidence. The blue and red lines show there's 10 times more iridium in the Sudbury rocks than in control samples from normal Earth crust. This is indisputable proof.
No music today. You guys got enough of it inside the Instagram itself. So I figured that I could just not have it and you guys could talk and you guys could listen to whatever they're playing in the background.
The landscape here is flat as far as the eye can see.
There's a little bit of onions.
Over millions of years, the crater disappeared. Erosion wore it down until all that is left is the faint outline of ring structures seen on satellite
pepper.
images from space.
Cut into it.
Spray and his colleagues have surveyed the area and found that Sudbury is the second biggest impact site on Earth. 155 miles in diameter. That's 3/4 of the size of the world's largest crater at Vredefort in South Africa. Spray calculated almost 2 billion years ago. A space rock the size of Mount Everest must have crashed into Earth here.
I'm going to get a little pan out here. I'm going to saute these. They're deliciously sauteed. And I think they'll add flavor to our dish. Just a little pan.
Software going back up through the projectile, the back blows off, and you end up fragmenting the projectile, the meteorite. So you may even end up with pieces of the sun projectile on the moon, and that's highly likely. So it actually gets blasted out into space.
But one question remains. Where did the valuable reserves of nickel and copper come from that turned Sudbury into a famous mining site? And the asteroid had vaporized, so the large nickel and copper deposits couldn't have come from space. When the asteroid hit, it penetrated almost 18 miles into the Earth, melting a huge cavity in the rock. Scientists estimate that this giant hole lasted only a short while. Within hours, it collapsed because of gravity.
It's just like when you try and dig a hole on the beach in sand. With your shovel, you're spading the sand out, and you can only go so big before the side actually collapse in.
After the cliffs collapsed, the crater floor filled up with a deep lake of hot.
So what's everybody doing these days? I mean, I know that June 10th is coming up. I don't know if anybody's going to... June 19th, sorry, is coming up. And Juneteenth. And I don't know if anybody's going to be doing anything for that. Picnics, I'm sure, will be going on. Anybody going to any of those? Don't know. Tell me in your comments. Any special camping trips, anything going on before the 4th of July?
Into awesome mining deposits.
I got to walk up to Sioux Falls, or Silver Falls. That's some of the pictures that I posted there on Instagram just recently.
Potentially meant big business and economic wealth.
Take that, and we're going to add a little bit of butter, some butter to it, saute those.
Now use satellite imagery to reveal the craters around the world. Rings that can can be seen from space suggests giant asteroid impacts. They know that these impact sites may contain more.
We've also got the hominy over here going, which I'm going to drop some of the butter into that. It's just about finished, as you can see. Let me look for you. See, it's all nice and going. And get some butter, drain it off a little bit.
What is now thought to be the biggest impact crater on the planet. Here, the impacts concentrated valuable minerals in the rock. This time into precious deposits of gold ore. And at Chicxulub, Mexico, scientists discovered traces of a large asteroid impact that wiped
Now we're
out
going to add
the
some butter to
entire
it.
dinosaur population 65 million years ago. But recently, scientists have drawn a link between the massive crater at Chicxulub and a huge oil reservoir discovered nearby. As the asteroid crashed into the Earth's crust, it fractured the underground rock, making it porous. Oil, abundant in the deeper layers below, rose up and seeped into the porous rock, creating an oil reservoir. Now scientists could more easily recognize signs of large impact sites. Shatter cones were evidence of strong shock waves. The presence of the space metal iridium was proof for an
That going?
asteroid impact. And satellite imagery has shown how impact craters can be linked to vast mineral wealth. Besides the minerals found at different impact sites, asteroids have left evidence of massive destruction. This has led scientists to a terrifying conclusion. It has happened in the past. There's little doubt it could happen again.